So, very good morning to all respected student members. Today, I welcome you all for the third module in manufacturing process. Here, in today's segment, we are going to see about various types of casting processes in manufacturing. What are the different methods of casting practiced in industry in the recent current scenario? Before moving to the main segment of the presentation, we will try to understand the session objective. The main objective of today's session is to study and compare the different variety of casting process which are available in actual practice within an industrial setup, and each specific type of casting process used to require high volume as well as small batch production by maintaining complex part geometry with a high dimension stability and accuracy. By using different wide variety of raw material, we can able to produce the parts in different variety of size and weights with relative mechanical properties with reduced finishing requirements. So this is the basic objective of the different types of casting process in manufacturing system. Now we will move on to the specific information. What are the different casting process, different types of casting process that are available in the industry that we will see as a literature survey. Here there are 10 different types of casting process are taken out, and each casting process has got unique advantage and disadvantages. So we are going to see all the information in nutshell. The very first type is sand casting process. It is one of the most old method of casting process in manufacturing operation. So sand casting is considered to be a more versatile method of casting process. It can able to use both ferrous and non-ferrous material for making the final end products. Normally, automobile parts like engine blocks and cylinder heads, crankshafts, these things can be prepared using the sand casting process. What exactly the sand casting process narrates? So from the diagram, it is quite understood that the process requires two pair of mold. One is considered to be a cope and drag. The other one is considered to be a drag. The mold material is made of silica-based material with a smooth surface on the exterior part of the mold. When the molten metal is poured into the pattern cup, it allows internal solidification in order to take the final shape of the product. Then at the last stage, the extra material will be trimmed off and final finishing of the metal casting product will be ejected out from the mold. So this is the simple mechanism carried out in sand casting process. Now, what are the merits and demerits of sand casting? So these are some of the few highlighting points are listed out here. So if you take the advantage, it is considered to be a relatively inexpensive, quite cheap method of manufacturing method process. Disadvantage, low degree of dimensional stability and accuracy will be found to occur while preparing the final raw material. We can able to create more number of large size components. Easy recycling ability of the material. Since sand is a easily recycling material, we can use for the next cyclic operation for making a casting product. High melting materials like steel and titanium is one of the most commonly preferred material for preparing the sand casting process. And moreover, from the disadvantage, the process yield of the product will have a rough finishing surface. And it is very difficult to use this method with the predetermined size and weight requirements. So these are some of the disadvantages of the sand casting process. Second one is gravity die casting. Gravity die casting can be otherwise termed as a permanent mold casting. This can be reused. The mold can be reused again and again for making multiple number of the casting material. Since the mold material is made of metal, say steel and graphite. So this type of metal casting can be used for producing final end commodities like gears, gear housing, pipe fittings, engine pistons, etc. So what is the process involved, mechanism involved in gravity die casting? A direct pouring of molten metal into the mold cavity takes place due to the effect of gravity positioning. Sometimes we can able to tilt the die in order to control the filling rate inside the mold cavity so that the molten metal is allowed to cool and solidify within the mold to form the final product. So as similar to sand casting, gravity die casting also has its own unique advantage and disadvantages. Let us see a few of the things as listed here. Compared to sand casting, gravity die casting provides better surface quality due to fast, rapid solidification process. Here, complex object is difficult to manufacture through gravity die casting. Next one is pressure die casting. So there are two different type of pressure die casting according to the range of the available pressure, low pressure and high pressure die casting. Normally, high pressure die casting is quite used for mass production. We can able to create a number of complex part geometries which requires high dimension stability and precision, whereas low pressure die casting is used for only small and simple part production. Following are some of the materials that are preferred. Non-ferrous materials are preferred for preparing the pressure die casting process. Say zinc, tin, copper, and aluminum. These are the preferable material that are injected into the hollow mold cavity with the high pressure. After the completion of the final process, the extraction of the cast product will be taken away from the mold. So the advantage of pressure die casting and disadvantages. So high precision and dimension tolerance can be attained. Heavy tooling investment cost is required for installation of pressure die setup. Fourth one is investment casting. This method can be otherwise referred as low wax casting. So in this process, the wax used as a pattern material protected with a refractory coating and a binding agent. Investment casting is quite high, costlier, expensive, and it requires more amount of labor skill to control the manufacturing process in large scale in mass production. The type of end items produced from the investment casting, say gears, bicycle trunks, motor disc, and the spare parts that are utilized for blasting machines, etc. So advantage and disadvantage for investment casting. So it can able to produce parts with the thin sectioned area of cross section with the better high complexity and surface quality. It requires more number of labor skill to control the operation. Next type is plaster casting. Here plaster of Paris is a material that is used to prepare the mold. It is more or less similar like a sand casting. So here the plaster of Paris has low thermal conductivity and heat capacity. So it cools the metal more slowly as compared to the sand casting with high dimensional accuracy. Moreover, this type of process will not be suitable for high temperature ferrous material. It produces smooth surface finished parts. The process tends to be more expensive compared to the other method of casting operation. Next one is centrifugal casting. Centrifugal casting can be otherwise considered as roto casting. Normally, this type of the casting process more preferred for manufacturing cylindrical parts with by applying the centrifugal force on the die. So this type of metal casting uses a preheated spinning die in which the molten metal is poured. Due to the applied centrifugal force, the molten die rotates in a circular motion so that it will evenly distribute the filler material, that is the hot liquid molten metal inside the cavity at a very high pressure. Here in this process, material wastage is reduced, so high process yield we can able to expect. Centrifugal casting setup requires high investment cost. Next type is lost foam casting. Here, foam is a material that is used for preparing the mold. Here, the type of alloy that can be processed for making the final components, say steel, carbon steel, alloy cast iron, ferrous alloy, etc. Using this, we can able to create final end items like fire hydrants, walls, and fittings. So these products can be manufactured through this foam casting method. It is considered to be a high precision casting method. The pattern cost will be much higher and it is most suited only for low volume production. Next one is vacuum casting. Next classification, vacuum casting. In this process, the molten metal is considered to be poured into the hollow mold cavity, which has a vacuum chamber in order to eliminate the air bubbles or air pockets inside the vacuum chamber. The vacuum evacuation of the die cavity tries to reduce the entrapment of gas inside the hollow mold cavity during the metal injection process. Thus, the metal is cured inside the heating chamber and it is removed from the mold. So here we can able to reduce the mold, the casting defects like porosity. We can able to improve the surface quality of the die casting. High tooling investment cost is required. for installing the setup of vacuum die casting. Next type is squeeze casting. This can be otherwise called as liquid forging method. So squeeze casting is a hybrid metal forming process that combines permanent mold casting and die forging in a single step. In this process, specific amount of molten metal alloy is injected into the die and the external pressure is applied to shape it. Therefore, the metal part is heated over the melting temperature and then finally it is extracted from the die after the completion of the process. So squeeze casting eliminates the internal defects like cracks, porosity, shrinkage, etc. This method is considered to be less flexibility regarding maintaining the stability of the part geometry. Next type is continuous casting. So this method is used for mass production of metal profile with the constant area of cross section. Normally, steel billets, steel bars can be done by continuous casting. So here in this process, different range of the metal billets slabs can be produced with a different varying size. Next one, requirement of continuous cooling of the mold. The mold has to be kept continuously cooled throughout the process. Otherwise, the material shrinkage problem will be developed during the solidification process. Now, with this information, I conclude the different types of casting process. So in this segment, we saw various types of casting process. In addition to that, unique standard merits and demerits for each type. Now, in nutshell, casting process are not only classified according to the mold material, method of filling, it is also classified according to the type of casting preparation methods like expandable mold casting, permanent mold casting. The main choice of the process primarily depends on the following factors like desired shape, part complexity, amount of metal being casted, required final quality, etc. So these are the crucial factors that are considered for the entire success of the manufacturing process in the industry. So with this information, I thank all the student members. We will meet in the next module number 4, different types of casting defects. So with this, I thank each and every one of you. Thank you all.